Okay, so what we've got here is hypothesis testing, and this is the video that I promised I'd make for you. Um, what we're going to do is look through a couple of examples. The first one's going to be just a straight one-tailed hypothesis testing question, and I'll show you step by step why we're doing the things we're doing. And then we'll try a slightly harder one where we have to reject or accept a null hypothesis. Right, let's just test this hypothesis here. Well, you're going to have to reject it or accept a null hypothesis, whatever happens. But the second one's slightly more complicated of an example. So let's just summarize this question first of all. We're talking about this woman, Elaine. She's rolling a dice. She thinks that 1 is coming up more often than expected. She rolls the dice 30 times and she gets the results that you can see in the table here. So we're testing at 10% significance level, and that does answer one of the questions I often get asked. Is it always 5% and 1%? Not necessarily always. It can be a 10% as well. So let's just set up our hypotheses. What are the hypotheses? The null hypothesis is that the probability of 1 is 1 in 6, just as you'd expect from a normal dice. Remember, null hypothesis is always status quo. H1 is that the probability of 1 is greater than 1/6, so it's biased, and it's biased in favour of number 1. That's why it's a one-tailed test rather than a two-tailed test. We always assume the null hypothesis is true. So what we're going to do now is have a look at some of the calculations that you're going to have to do. Here we're going to be testing the chance of getting 8 or more. Why is it or more rather than less? The reason why is given by looking at H1. We're looking at the chance of the probability being greater than 1/6. So we want to test what is the likelihood of getting 8 or more. Alright? Now what I'm going to do is I'm going to fill in the gaps here and then talk to you about how and why I filled in them the way that I have filled in them. But hopefully that's made sense so far. We've set up our hypotheses, we're testing them at 10%, and now we're going to have a look at the probabilities. Okay? So I'll be back in just a moment with it all filled in. Okie dokies, here we are. We are looking for the probability of 8 or more, which would be 1 minus the probability of 7 or less. That's why, if you see in the working, it's actually given us to do 0.8863 even before thinking about the probability of greater than or equal to 8. But I've kind of just explained that. That's why that is the way that is. We're looking for the probability that's greater than or equal to 8, so we're looking for 1 minus the probability of 7 or less. This number here is 0.1137. Now, I'm going to be honest with you. I've just looked up the tables on Google and I've done an approximation. It's about that. It's bigger than 10% any which way. So there's no evidence to reject the null hypothesis. So we're going to have to conclude that the dice isn't biased. So that's how that works. If that probability had been lower, if it had been like 5% or 7% or 8%, we would have rejected the null hypothesis and would have accepted the alternate hypothesis. Remember the truth of this though. We're not proving that the null hypothesis is true. All we're saying is we haven't got enough evidence to reject it. Okay, and that is a difference. But hopefully that makes sense. We're going to look at a slightly harder one now. Okay, so have a look at this guy here, where we're looking to find some critical regions. Now, you've got an example of critical regions before in a previous video. It's well worth doing another one. This one's a nice two-tailed one as well. So let's have a look at this. Let's first introduce the question. We're talking about peppered moths, which is a type of moth. It's got nothing to do with pepper or flavour. No one's eating the damn things. They're just sort of peppered. I don't know what that means, actually. I'm not going to lie. I suspect it's got something to do with the colouring of them. So in this village, 20% of these moths are dark. Pollution affects moths. I think this is like one that they always teach as an example of like evolution, where like when we had the Industrial Revolution, more pollution got pumped out. So everything was dirtier. So like the moths that were also darker kind of had better camouflage than the moths that were lighter. I can't remember. This story was like that. Why am I telling you old man stories? It's not relevant. Anyways, so let's get back to the actual question. It's a sample of 30, 10% significance level. We're testing it. We're not actually testing it this time. What we're doing is we're finding critical values. We want to find out where are our boundaries, how many moths would we need to catch to see whether pollution levels are changing. And that word changing is key there because we're not doing a one-tailed test. We're doing a two-tailed test then. Because it's not, is it getting worse? It's not, is it getting better? Is it changing? It could be either. So what I'm going to do now is obviously fill in this answer. And then I'm going to talk you through why I've made the decisions I've made in this question and how you can take that and extrapolate that for your learning. Okay? And you can see that I haven't bothered doing all of this. One thing I should have probably put in is the H1, and the H1 is P is not equal to 0.2. So I apologise for not doing that. I'll pop that in just a second. Okay, that's much better. So what I've done there is look for the probabilities that are as close to 0.05 but are less than. Now that's not always the case. Sometimes they say insist on it being as close to 0.05, even if that means it's slightly larger, and you just kind of got to roll with that. But this is not what we're doing here. And if you actually wanted to know what the what the actual probability is, it wouldn't be anywhere near 10%. It's somewhere around about somewhere like 6.9, or maybe even just around about 6.9%, not 10% at all. So interesting facts. We don't really care. First one's really easy. Just find the first one that's less than 0.05, which is 0.0442, and that comes at 2 or less. The other one is more challenging because it's the one that people intuitively don't really understand why. What you do is you pick the first one that punches over. So in this case, that would be 10. But then you realise if you're going to be 10 or less, logically then you are 11 or more, and that's really where we want to be in terms of having a critical region. So one tail that's less than, one tail that's more than. So 11 is your actual value here in terms of that. Annoyingly, the way the solution is phrased, it talks about catching fewer than 3. So that makes sense. Like if you're 2 or less, you're fewer than 3. Or more than 10. So you almost go back to the number that you started with, and like all that stuff. And it's a lovely question in that, because it really kind of forces you to see whether you understand this stuff or not. Because it's very, very tempting to just go, okay, here's the rule, add 1. Every time, add 1. Every time. But like here, the way they phrased it, they want you to be more, greater than or equal to 11 means more than 10. And that's what, so even though you use 11, you need to go, well, keep your idea of how do inequalities work. And if you're saying that we are greater than 11, when it wants you to fill in the gap for more than, it's literally more than 10. All right? So it's kind of a tricky question. Not too bad though, I would have thought, and hopefully that does make a bit of sense. If you're confused by any of it, do drop me a message and I'll be happy to explain.